So we ran the fit method on our model, and it has completed the 10 epochs. And as you can see, the accuracy is 0.995, so that's pretty high. But that is the accuracy on our training data. And if there's overfitting, of course, the accuracy on the test data might be a lot lower. So let's look at that. So let's evaluate, evaluate on test images and test labels. Yeah, and as you can see in this case, the accuracy is 0.977. So it's a bit lower, but not a lot lower. So there doesn't seem to be an awful lot of evidence for overfitting. And actually, we're going to look at this in the next video to see at which number of epochs that we can specify that the overfitting starts to kick in. So now let's have a look at what a prediction actually looks like. So what does it mean for the model to predict a certain number? So we say predictions is model.predict. And for each test image, I want to have a prediction. So let's look at the prediction for the first image in our test data set. So when you evaluate that, we find an array. Yeah, you can count by hand, but there are actually 10 numbers in this array. So you can see that this is indeed 10. And these numbers were generated by our softmax activation function. So when I actually sum this, so let's print the sum of these numbers, then you can see that they add up to 1. Yeah, because it's exactly what softmax does. It gives a probability distribution across the different labels that we have. So we have 10 labels here, namely the numbers 0, 1, 2, 3, all the way up to 9. So if you look at this array, then this number here gives you the probability that our neural network thinks that the first image is a 0. And as you can see, this number is pretty low. Yeah, so just recall this scientific notation. Basically what it says is this probability is 7.89 times 10 to the power minus 10. Yeah, so that's a pretty small number. It's very close to 0. Yeah, it's also highly unlikely, according to our model, that the first image that we have in our test data is a 1. It's very unlikely that it's a 2, etc., etc. And as you can see, by far the biggest number, so the highest probability, is on this entry here. Yeah, so that's the 8th element in this array. But since we start counting at 0, this is label 7. So the probability, according to our model, that the first image from our test data is a 7, that is basically 0.99, so 99%. Yeah, this says 9.99 times 10 to the power minus 1. Yeah, so this is very close to 1. So our network is pretty sure that the first image that we have in our test data is a 7. Yeah, so we can actually specify this a bit more precisely. So I can say, what is the index? So I'm using the argmax here. So what's the index which is the highest in my vector predictions yeah, so that happens at number 7, at the 7th, the position with index 7, so I can actually print this. And then I can compare this to the label that goes along with this, and I also want to know the label of the first image, and that is a 7 as well. Yeah, so our network is pretty sure it's a 7, and it turns out that the correct label is indeed a 7. So just to be sure, if you want to check, we can look at what the handwritten number actually is. So test images, the first element, and indeed that looks like a 7. Yeah, so if we had to judge this thing ourselves, we would also say it's a 7. In the notebook, we actually sort of automatize this process, and we plot for quite a few numbers. We plot the number itself, the prediction, and the correct label, and then you can see, you know, that usually the network actually gets it right. Yeah, so I'm not going to repeat that here. You can check the code for that in the notebook. That plots for a number of the predictions, the prediction that you would choose, so the one with the highest probability, and compare that to the label, and compare it to the handwritten figure itself.